This is the leak monitoring presentation, the fifth out of 12 training modules in the Underground Storage Tank Class A and B Operator Training Program offered by the New Hampshire Department of Environmental Services. This presentation is narrated by retiree Spruce Wheelock.
So leak monitoring is the content. We'll go over some of the leak detection items such as line leak detectors. We'll go over requirements, operation, of course, testing. This is an example of an underground fiberglass storage tank. We have a double wall fiberglass tank here. We have dead men here that hold the tank down from floating with straps. We have a submersible pump in here, pumping up into a sump on top of the tank. We have our piping. It goes into a sump under a dispenser. The piping may actually go into the building to, let's say, a heating oil tank. And we have a leak monitoring system on the side of the building, inside the building generally. Double-walled tanks, piping. So everything in New Hampshire, we're lucky, is currently double-walled with a sensor at a low point. So the sensor would pick up if there's any contamination or liquid in there, send off an alarm to your leak monitor sensor. So if we had a leak up here in a dispenser, for example, it'll drop down here into a sump underneath the dispenser. There may be a sensor in there. If not, we have what we call double wall piping, so it would all run down to the sump on top of the tank where there would be a sensor. And of course, we have the double wall tanks, which have a sensor to pick up any type of leak. But that's basically what a leak monitoring system is. So the consoles for the leak monitoring systems, generally here in New Hampshire, most of them what we see is Veeder-Root. These are electronic leak monitoring systems, an older type or a slightly newer type. Then there's also petrometers. We have some petrometers out there for the double wall tanks, and we even in the old days used to have some in situ, which I haven't seen recently. Now the in situ, when I was doing the inspection, I asked where his leak monitoring system was, and he says, "My what?" He says, where's your leak monitoring? It checks your tank for leaks. Oh. So we walked around the station, and this is what I found. I says, "That's your leak monitoring system." Oh, I've been here for 10 years or so, and I was doing some work and rehabbing and cleaning things out. I was going to throw that rip that off the wall and throw it away because I had no idea what it was. Well, sir, we opened it up and we looked and we see it's battery powered. And if you can see, the battery had exploded. And the manufacturer requires that battery be replaced every 9 months. And if he'd been there for 10 or more years and never replaced the battery, his leak monitoring system probably didn't work after the first year or two that he was there because the battery had exploded. So what I'm trying to imply here in this slide is that there are many types of leak monitoring systems out there. I've seen over 100 different types. I have not figured out all of them and how they all work. Okay, we're not expected to. There's so many. But what I want to imply to you guys is you have a leak monitoring system. You need to know how your system works. You need to know how it works. So the next time you have a contractor coming out to do service work, talk to them. Have them show you how your system works. Now the leak monitoring monitor has to have an audible and visual alarms. Has to be labeled, such as underground fuel tank monitor. Because when you train your C operator and they come out and they look at this unit and it says a TLS 350R, what is that? I have no idea. So get it labeled what it is so that when they call you at 2 o'clock in the morning and say this thing's beeping and flashing and they're running out of the building thinking the place is on fire or the boiler's going to blow up, it's labeled and they can talk to you and you can talk to them and figure out what's going on. It's also required to have the sensors labeled, okay, such as example here would be L3, which is your regular tank piping sump. And we have it all listed up here what the sensors are. And why that is so important, one of my inspections I did years ago was I went to a site and we were doing our state 3-year inspection, and the contractor got there and looked around and he said, "Oh, this site." He says, "I was here in February because I was on call as the service guy. And I got here and the system was an alarm. So when I got here, it was about, I don't know, 7 o'clock in the morning. I got the call about 3:30 in the morning that the system was an alarm. So the owner shut the whole place down. Well, it took me until 4 o'clock in the afternoon to find out what sensor was in alarm. You have to understand there was probably 8 or 9 tanks at this site. There were over 18 sensors. And of course, good old Murphy's Law, the last sump that I got into where there was a sensor was the one in alarm. And being in February, I had to chip ice in order to get access to a lot of these sump locations. So unfortunately, the owner was down and out of selling product through the whole day. He couldn't sell his bulk heating oil, his above ground tank heating oil, his underground tank heating oil, his diesel, his kerosene, and of course gasoline. So he lost a lot of money. So we need these things labeled so we can act and you can act and the contractor can act appropriately. This proper operation? I don't think so. You think he's ever looked at the slips to figure out if there was an alarm or a problem? Maybe, maybe not. Who knows? But no, I would not consider this appropriate record keeping. Double wall tank. And what I mean by double wall tank means that we basically have a tank that's built inside of another tank with a little space in between. Here's an example of a fiberglass tank. In that little space is only probably an 1/8 inch, 1/4 inch thick between the two double wall tanks. Unfortunately, I can't show you that here because normally in class I hold up an example. But there's just a little itty bitty space in between the two tanks. So if the tank on the inside that holds product leaks out into that little space, it runs down to a low point where you have a sensor. Types of sensors. We have a typical float, maybe an optical. Okay, there's many types of sensors. We have a pressure switch for that petrometer system. And all that does is liquid fills up in here, it compresses the air, and it sends it up to the monitoring system, which has a pressure switch. Now, most people, like I said, in New Hampshire have a Veeder-Root leak monitoring system, and what most of those have is what I call a bell sensor, because it's shaped like a bell. And inside here, there's a little float, which I would show you in class, but all it does is go click, 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 click. You shake it because it slides up and down. It's a little float. It'll float up and set the alarm off. Now, this sensor, of course, for it to work properly, has to be set at the very bottom of the tank. And the reason for that is, of course, if you have a leak in the top of the tank, it will run down to the bottom to where the sensor is. So if you just keep having the sensor, halfway up, you would have to fill this whole interstitial space between the double walls all the way halfway up the tank. And if you have more than one leak or something, then it might be leaking out and never set your alarm into an alarm. Who has fiberglass tanks? I can't see anybody, but we do have a lot of fiberglass tanks. This is tough teaching without an audience like I'm used to. And again, a lot of these fiberglass tanks have a float and sometimes optical, and it wraps around the outer part of the tank down to the bottom. It's just a different type of material tank and a different type of sensor. Now, with fiberglass, there's also what they call as a brine system. Now, for a brine system, which is a liquid that they fill this interstitial space up into a well here where they put the sensor up in the top of the tank. And what the brine is a mixture of salt and water so it doesn't freeze. And what it does is it fills this whole space up around the tank up to this well. So if that brine leaks out or the tank leaks into into the brine system, there's a high and a low sensor, so it either fills it up or it drops, and it sets the alarm off. It's just a different type of leak monitoring system. We call it a wet system versus normally that double wall is dry. Piping and sumps. Here we have a dispenser and the sump underneath, and this particular has a sensor. So if there's any leak in this dispenser itself, it drops down into the sump where there may not be a sensor. And if there is no sensor, the product or liquid will run down the double wall piping down to a sump on top of the tank or a low point where there is a sensor. So everything is double walled at a low point where there is a sensor to pick it up. If you drive into a gas station, you drive over these 4-foot covers. Clunk, clunk. Underneath that is your tank and your piping sump with a sensor. Just a typical layout. So if you drive into a station, you see all these round covers. Underneath that is your sump, and underneath that is your underground tanks. Double wall piping. We've had many types submitted over the years for approval. We've had rigid fiberglass, 4-inch and 2-inch, some of the little distances between. We have a lot of flexible double wall piping that's been submitted over the years, a lot. We've even had steel piping that's kind of corrugated to be flexible with a plastic type outer double wall. Now, normally I'd hold up an example of some of this double wall piping, and what it is it just has a little itty bitty space between your product piping and your outer piping, and there's usually some little ridges in here so that it keeps the two pipes separated. And so if there's a leak from the inner pipe, it'll get into the space in between the outer and run down to your low point into your sump. The example here is if it leaked out of this primary pipe where the product is and into this green pipe, it would run all the way down the green pipe until you get into a sump and set the alarm off. Fittings. In sumps, they have fittings to test what we call, here's your product piping, here's your secondary piping, which is your outer wall, and there's, like I was saying before, a little itty bitty space between the two. Well, they have what they call as a test boot, and the test boot's on there so that they can put pressure between the two pipes to see if this outer pipe is tight during installation. Well, they need to slide this boot back after they do the tests, all right, just like this, so they can expose that seam. Otherwise, if you leave it on here and you've got a product that leaks into this green double wall piping, it can't get out into the sump where the sensor is. Can't set the alarm off, so you're defeating the whole purpose of your leak monitoring system. Here we have a good 4-inch double wall piping where the product piping is 2-inch, and yes, he pulled the boot off so that any liquid that gets in there can get into the sump to the sensor. Here we have a heating oil system. We have some copper piping and a donut that would normally go in here so that you can pressurize through this point to test that big double wall secondary piping. But he's got to open that up after he's done the test so that we can get product out into the sump to the sensor. Here we have a dispenser sump with what we call as a jumper. And then what the jumper does is if there's a leak from this primary line up here somewhere, we have this connection on, it'll jump from this line to this line and run from one dispenser to another dispenser to another dispenser down to wherever the low point is where there's a sensor. And with our new regulations here, we need to monitor under all the dispensers. So this dispenser sump here does not have a sensor, so a sensor would need to be required, or these jumpers have to be removed in order for product to get to a sensor. For example, here we have a jumper. So if there's a leak up in this upper section, gets down to the jumper, jumps and gets into this second line that goes from one dispenser to another dispenser. Here we have the same scenario. We come down to, oh, we have a plug. Well, if we have a plug in that section right there, it's not open. So if there's a leak in that the primary pipe up in here into the secondary, well, it stops right here and it can't get out into the sump or down the line to get to where there's a sensor. So that needs to be opened up, just like these are over here. These are opened up, and that's fine, because if you have a leak up here, it comes down, comes out of this hole, fills up into the sump, gets into this hole, goes from one dispenser to the next dispenser to the next dispenser down to a sensor. Here we have rigid fiberglass piping. You have your product piping and you have your secondary piping. This is what we call as a test boot, which is made out of fiberglass, and we have a plug in there. Plug. We can't have a plug because if there's a leak in this line up here, it can't get out, just like that other scenario. So I had the contractor remove the plug, and this is what happened. He come jumping out of that sump so quick. Luckily, this was not gasoline. It was just plain water. So what had happened was, somewhere up the line here, the product piping and the secondary piping, um, the, the secondary piping had failed. So that groundwater, during seasonal high water, had got into the secondary piping, filled it all up full of water, so when we pulled the plug out, water come gushing out. So what this scenario means is that the owner has a failed secondary piping system up this direction that needed to be repaired and replaced. Here's some other test boots, different types. They were able to pull this one back. But what's right there is what we call a Schrader valve. Now the Schrader valve is the same thing you have in your automobile tire. All right, you go up and you connect your air gun to your tire and you pump your tires up full of air, and the Schrader valve holds air in your tire. Well, the same thing here. If you pump up this secondary area, it would hold air in there. But after you do your test, you need to either slide this boot back, as I was saying earlier, or if you want to remove the inner guts out of the Schrader valve, it would let the air rush right out through. Okay, just like your tire. If you take that inner guts out of your Schrader valve on your tire would go flat. Okay, and the same would be here. Now, if you pull the inner guts out and you didn't pull this boot back like this scenario, and you took that Schrader valve out, that is okay. Because if you have a leak up here, now, just like the air can come out, the liquid will be able to come out of that through that valve like this. Sensors. Here we have a number of different types of sensors for piping in sumps. We could be either a float or an optical. Here we have some opticals, and all the optical does is that if you get liquid in here, it bends the light and sets the alarm off. It's just a different method. Here we have a Veeder-Root sump sensor, which is one of the most common ones we see out there in the field. And again, it is a float. I did a little cutaway here so that you can see the float. And all it does is slide up, down, just by a little bit of maybe a half an inch or so. So you need about an inch of liquid in here to float the sensor up and set it into alarm. Here's another cutaway, another Veeder-Root. This is a different manufacturer. They call this a discriminating sensor. The cutaway shows a float there, shows a float there. And there's a little ribbon inside here that goes all the way up through and discriminates. It'll tell you if you have product or if you have water. So it discriminates between the two. There is also two sensors in here. I call this the idiot float. And the why I say that is it gets an alarm here, sets the alarm off to your monitoring system, and the liquid piles all the way up here, and it'll set off a high alarm. And I call it the idiot sensor because, hello, you had an alarm, you're supposed to take care of it and pump the water or liquid out of the sump and fix it. If it gets up this deep and sets off another alarm, you idiot, what are you waiting for? You're supposed to do it way back when. But anyway, that was just a little food for thought on my end. Here we have a sensor that discriminating that was installed in a dispenser, and they installed a float sensor beside it. Now, we may see more of this as we go along because of rules and regulations, but in this particular case, years ago, they did this. And I always ask the class, why do they have a secondary sensor there? Ding dong, ding dong. Well, nobody's responding. I can't hear anybody, unfortunately. You're missing out. And the reason for that is, in this particular case, the owner wanted to have a second sensor so that it would shut the actually electricity power off to that one dispenser. So if there was a leak of gasoline or diesel in this one dispenser and in this dispenser sump, they wanted to shut the power off. They didn't want to have any petroleum product in that sump and electricity running into it. They didn't want to have a kaboom scenario. So they opted to go above our regulations and put a second sensor in. Sensors and sumps. Here we have what we call a fiberglass double wall tank with a fiberglass sump on top. Well, here's the sensor. And I ask people, oh, okay, why do I have the question mark? Well, if you look, the sensor is not at the low point. There's liquid in here. It's up here on this little rib. The lowest point on these fiberglass sumps are on the sides because the way these sumps are manufactured, the lowest point are over on each side of the tank. So they had raised the sensor. So in order for you to properly determine if you have a leak or release is the sensor needs to be installed, hint, hint, at the lowest point. It also has to be set vertically. Remember I showed you the picture of this sensor with a cutaway and the float on the bottom. Well, if this sensor falls over, how's the float going to float? Because it doesn't float sideways, it's got to float up and down. So the sensor needs to be secured so it doesn't fall or float over. And then the other one is this question mark. Oh, why do I have that one? Well, I can't hear anybody answer again. But we have these heating oil line here going up through, and this is your double wall piping. And the facility AB operator said, well, gee, about every February here, I get the monitoring system going into alarm, and I have to chip the ice off the top of the cover, get in here, and I have water in here, and I have to pump it out. Well, last year when I was in here, I saw water dripping out of this secondary pipe. So I said, aha, that's where the water's coming from. So I went down to Home Depot, got some spray foam insulation, and sprayed that sucker right up in there and plugged that hole up. Yes, sir. Now I'm not getting water into the sump. Oh, guess what? He just bypassed this whole leak monitoring system because if this heating oil and these copper lines up here leak out into the secondary space, it would fill up that space and leak out into the environment or wherever that groundwater was leaking in the first place. So he basically bypassed and messed up his whole leak monitoring system. Remember, that secondary space has to be remained open. So he had a secondary piping that had failed and needed to be replaced. So hint, hint here is the secondary piping has to be open, sensor has to be at the low point, and the sensor has to be secured so it doesn't fall over. Here we have a sensor. It's not on the bottom. They've actually slid it up in the air because we got liquid in there and it was going into alarm. They said, we can fix that. We'll just pull the sensor up. Well, in this particular case, I got sick of that blinking light and all those noise and harm, so I fixed this. I just take the sensor and stick it up on top of the piping. No, 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 can't do that. And sometimes they do this because you have a service contractor. Oh, well, we're getting water here in the sump. So you called me up, I came out, and I pumped out, a couple 5 gallons because that's all it was on the bottom. And you do that every week or two. I'm getting sick of it. I'm going to save you some money. I'll just put the sensor way up here on top of the piping. And so that the next time it goes in alarm, you call me, I'll come out with a 55-gallon drum and I'll pump all this water out of there. So I don't want to be coming every couple of weeks. No, you don't want to do that because there might be another hole right here, another hole right there. And so that if you got a product leaks out of the piping, leaks out here, but it's going to leak out those holes before it ever gets to the sensor. So you never know that you had a release. So you bypass the whole leak monitoring system. Here we have a dispenser sump and a leak full of gasoline. I came here to do a test, vapor recovery testing on the tank systems and piping and so forth, and line testing, and we couldn't get it to pass. So what we tracked it down to is this sump was full of water, no, full of gasoline, excuse me. And so we had a pump truck come in and pump out all the gasoline. We have a jumper here, and so that's fine because we have a sensor here in that dispenser sensor, which is fine, doing just what it's supposed to be doing. And in this particular case, the sensor was submerged and was an alarm. So when I saw this, I walked into the facility leasee at the time and asked, "What is going on? I see the monitoring system alarm, and did you know about it?" "Yes, I knew about it." "So what did you do?" "Oh, I called my manager, the owner, and so forth, and talked with them." "And?" "Well, the owner says you're the new leasee that just started, a couple days ago. That's your problem. You take care of it." And the leasee says, "Well, I don't own this equipment." And so they were both pointing fingers at each other. "You take care of it. You take care of it." And of course, nothing happened. Well, what we did find out after we pumped it out and did testing is we found out this T elbow joint, whatever you want to call it, was leaking. So that's where all the product got into the sump. But I want to point out here is in regarding to regulations. If you have a sensor that goes into alarm, you have 15 days to get that fixed. "Well, it's been an alarm, he's not doing it." You got 15 days. After the 15 days, you need to get somebody in there and pump the tank dry. In other words, if it's a 10,000 gallon tank, you got to get a tanker in there and pump 10,000 gallons of product out of your tank, put it into temporary closure until you decide where the problem is, get the problem fixed, and reset your sensor. Ah, well, you're going to lose a lot of money doing that. And the reason for that is you cannot operate a system that's in alarm. "Oh, it's just water." Well, it may be just water that's in alarm today, but who knows tomorrow it's still an alarm. You haven't fixed it, and now you got a product leak, and you just assume it's still water. So you cannot operate more than 15 days. So do not put that black electrical tape or duct tape over the light so you can't see it, and do not silence the buttons. Annual testing. The leak monitoring needs to have hint on annual manually tested sensor test once a year. It's an annual test. Hint. You manually have to flip the sensors to make sure that they're working properly and they reset. So once a year, manually, test all your leak monitoring sensors, fill out the state form, and submit it to us at the Department of Environmental Services. When I go out and do an inspection, I say you're in non-compliance with your leak monitor test. "Oh, no, we've done our test." Yeah, but if I don't have a copy of the test on the state form or facsimile of on file, you're in non-compliance. So, well, I thought the contractor mailed it to us. Hint. Contractors are not required to mail in testing. Only time that they're required to notify us is if a tightness test, if you're doing a tightness test and it fails, they're required by rules and regulations in the law to notify us and the owner. Other than that, for doing just a leak monitor test, they're not required to. Granted, you may in your contract with them require them to submit it to us, but legally The owner is the liable person that is required to submit testing to us. So please go on to One Stop to see if the testing has been submitted to us. If not, please make sure it is submitted to us by yourself. Day tanks. A lot of facilities now have day tanks for emergency generators and heating oil systems. We are now looking at these and regulating these because it's a funny scenario where we've had to respond to heating oil tanks where there was a release from a day tank. The product was running down the hallway of schools, and then you shut a school system down for 2 or 3 months. The townspeople just plain go bananas and ballistic because the kids cannot go to school. So now we're helping out the fire protection and also looking at day tanks. So if you have a day tank, make sure that your contractor, when they come out and do their annual testing of the leak monitoring, that they check the double wall space here of your day tank and check your sensors. Monitoring systems. Anybody out there have OMTEX? Okay. Now, why I'm talking about OMTEX is they've been around a very long time. Just like my automobile. I've never had an automobile that I had for 20 years and never broke down. Same with these. Some of these have been out there for 20 years, and they do get, these are now very sensitive to power surges, lightning strikes, and what happens is these lights sometimes will just blink on and blink off when you try to press the test button, and it won't stay on. Same with the horn. And what we're finding is there are some boards and other problems that crop up. So if you got this type of leak monitoring system and you know you've had some power surges or power outages, please shut the power down for 2 or 3 minutes and then reboot it and make sure that all your sensors and everything else is cleared and reset. We don't want to have a system not working properly. Pump methods, well, there is the suction where we have a pump that's in a dispenser, or let's say your boiler system in your heating oil system in the building, where you suck the product up out of the tank to that pump. And the second method was what we call pressure, where the pump is actually down in the tank and you're pushing the product up to a dispenser or to your boiler or to your day tank. Suction. Here we have a sump on top of the tank, and we're sucking the product up out of the tank to a dispenser. Here's where the pump is. Another scenario is you have a boiler for your heating oil system and the pump, and you are sucking the product up out of the tank here to your boiler. So that's a suction type of layout. Whereas the pressure, as I said, the pump is down inside the tank, pushing it up through the head of the pump system here out the piping to a dispenser, or it's pumping and pushing it all the way out to a day tank. But what I want to point out here, we have a lot of problems with the new um, petroleum products out there, such as ethanol and diesel. Here we have meters in this dispenser here and a pressurized pumping system. And on the ends of meters, we have what they call as an end cap. And every time I go out there and I do my yearly or monthly inspections, I check under all these meters for drips. And I keep finding a lot of dripping going on. And I may need just these 4 little bolts here tightened up. Or I maybe need a gasket replaced. Other things to look for when you're in the dispenser here is, here's your filter. And it's weeping at the top of the filter and dripping down and staining. All you need to do is take that filter and give it a little twist. That's all it may need. But the whole intention is to inspect these and look for leaks. Now, I usually ask the people in class, here we have a dispenser and there's something going on I do not want to see, and what may that be? Ding, 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 ding. Let's see, I'll give you a minute. All right, here we have 1 and 2 empty filter. Well, not, they may be empty now, but There were the old filters that were taken off and replaced with new ones, and they left the old ones here, full of gasoline. And of course, over time, they evaporate. Well, in this scenario, I did is I walked into the store and asked the facility owner, which she was there, to come out, and I showed him this. And I says, "Well, sir, you could care less about customers and employees at this location." Huh? What do you mean? I says, "Look at this. Here we have some filters. They were full of gasoline when they were removed and replaced with new ones. Well, they are left inside this containment here, which is an enclosed space. And the last time I checked, we have electricity and wires in this enclosed space." Uh-huh. Well, if we got gasoline vapors all evaporating up in here, and if you get a little spark from the electricity here, kaboom! Ah, that's all right. We just eliminate a few customers and employees. Yeah. Yeah, you could care less about them. So the reason for these inspections is to look for possible problems. So if you got dripping going on here, you got vapors in here. You got dripping going on, leakage, you got vapors. You got old things sitting in here, old rags down the bottom in the sumps. Get rid of that stuff. An accident waiting to happen. I am trying to help you maintain compliance, protect the environment, and definitely protect people. Line leak detector, such as for release detection. This is for pressurized piping and pressurized piping only. The pump's down in the tank, pumps it up through this pump head, and we have a line leak detector for pressurized pumping systems. Here we have an electronic line leak detector. A lot of them out there have what they call as a mechanical leak detector. We have vaporless, we have FE Petros, and we have Red Jacket. All types of mechanical line leak detectors plus electronic ones. Now, what does a line leak detector do? Well, what it does is it's, excuse me, restricts or stops the flow if there's a leak greater than 3 gallons an hour. Okay. For example, there's nobody in the station pumping. You shut down for the night, whatever. You go to turn on their pump and their dispensers in the morning. First customer comes in. He wants to fill his car with 20 gallons of product. And he turns the pump on and tries to pump. It does not pump, or what we call slow fill. So he's just dribbling a little gas into his tank. That's a red flag. He comes in and tells you, well, the system's not working. And that is because when the guy tried to fill his car up and tried to turn the pump on, the line leak detector determined that there was a leak greater than 3 gallons an hour. So he would not allow the pump to be turned on. So this is to look for that huge gross leak that you may have. For example, times that we've had, well, during the fall, you got your contractor coming in to plow driveways, drive stakes around all the corners of the parking lot and driveway. They drive a stake down through your piping. Now you have a huge leak. So that's what this type of line leak detector is looking for. You do not want that guy turn the pump on and it's pumping 20 gallons in his car, but the rest of the 1,000 gallons is running out on the parking lot, down the street, into a catch basin and into the stream. We're trying to protect the environment from that huge, great big gross leak. And again, you need to have that tested on an annual basis, filled out on a state form, and submitted us for you to be in compliance. It's a manual test. Keep in mind, it's not one of these that you just press the button and check. It's a manual test where the contractor actually hitches up his equipment, causes a leak greater than 3 gallons an hour, and determines that the pump does not turn on. Well, when you call a contractor to come out and do your line leak detector test, ask him if he's got a replacement leak detector with him or he can get one quickly. I've had many facility owners tell me to tell you that, because what he's required by law is if it fails, he is required to shut you down. All right, that system has to be shut down until you get a new line leak detector installed and tested. Oh, okay. Well, I tested it. I have to shut you down. It's failed. I called my distributor. It's back ordered. I'll have one in about 2 weeks. Well, that means you're out of business and out of money for 2 weeks. So please plan ahead. I've had facility owners tell me, please, to tell you guys that. Hint, hint. Leak monitoring, line leak detectors have to be tested how often? Annually, which is once a year. Hint, hint. Okay. All leak monitoring, line leak detectors have to be tested on an annual, once a year basis. This is fairly new back in 2017. You need to do a tightness test of your tank system if you are a motor fuel dispensing system. And a lot of people say, well, it's just a kerosene tank. Well, kerosene, for example, a lot of truck drivers drive diesel and they will pump kerosene in with their diesel in order to mix that during the cold winters. So therefore now the kerosene tank, being that it's pumped into the truck, it is now a motor fuel dispensing tank system. Even though majority of it might be just for kerosene for heat, somebody's using it for their diesel trucks. Everybody should have done this by now, 2017, and of course you got to do it every 3 years thereafter. Well, as I was saying earlier, we never have floods in New Hampshire. Yeah, right. Well, here we are. This is actually Salem, New Hampshire, Route Route 3, right? 4-lane road right down through here. I came down to do a facility inspection. The underground tanks are right here. Needless to say, we could not do the inspection because the tank field had been flooded. Unfortunately, when I took this picture, I tried to get right here a picture of a rowboat with the fire department rowing down this 4-lane road. Unfortunately, I missed it in the picture. Darn. Well, I got there the next week to do the inspection and we opened the sumps and this is what I found. Okay. What I want to point out here is these things. That is 240 volt to this pump motor. Exposed wiring, more exposed wiring. I thank God I never waited and walked through that water because I didn't want, that was an accident waiting to happen. So what I'm trying to imply here, be ready for anything to happen to your facility. Maintain it. You never know if you get a flood or some weird thing that would happen. You want to protect the environment. You want to protect your employees. So please maintain your.
In review, leak monitoring is a requirement for all underground storage tank facilities in New Hampshire to be in continuous operation, to have audible and visual alarms. Those with sensors need to be maintained and labeled, and those with release detection and line leak detectors need to have their leak monitoring and their line leak detectors tested on an annual basis.